Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 86 of physics. I hope everyone will be all ear when I give my important lecture on the laws of refraction. So let's get started. Before summarizing the two laws of refraction, let us first perform an experiment which will pave the way for those two laws. In this experiment, we will need the following instrument. Number one is rectangular glass block with one face frosted, two rays of boxes, piece of paper, and in fact a protractor to measure the incident angle and the refracted angle. So let us start the experiment. In the first case, the ray box 1 is incident, a light ray perpendicular to the normal, and it is passing without any deviation. So, in case of incident rays perpendicular to the normal, there will be no deviation and no refraction of light will be observed. But one thing is for sure, and that is the speed of incident rays in optically denser medium is slower than as compared to the optically less denser medium air. That is the one observation we have to make. Now, in the second case, we have to vary the angle of incidence through ray box 2, and we will observe the corresponding angle of refraction. We have to observe the two rays of light and then vary the angle of incident I and measure the angle of refraction. Now, the following observation can be made from this experiment. The first one is the ray of light from the ray box pass straight through. Number one is the ray will pass straight through. As you can see that in the ray box 1, straight through without any deviation. This is the first observation we made. The second one is the ray of light from ray box 2 bends towards the normal. So we have to write simply bends towards the normal. Keep this in mind that this dash line is a normal, and this ray when entering to the denser medium, it is bending a bit towards this normal. So this is the second observation we have to observe. The angle of incident I is larger than the angle of refraction. Angle of incident I is larger than angle of refraction. As in yesterday's case, in case of two laws of reflection, we observed that incident ray and reflected rays are of the same measurement. But in this case, incident ray, which is this one, is greater than the refracted rays, which is this one, and you can observe this very clearly in this diagram. The third observation, we can summarize it here. The light ray bends away from the normal as it passes out through the uh, glass block into the air again. So I can write that bends away, bends away when getting out from glass to air. In this case, you can see that this is the normal and this outgoing ray is getting away. Here it is more closer to it, but you can see here that this is getting away from this. So this is the third observation. The fourth observation is that we are summarizing all these results in the form of a table in which I and R are given. So you can see these all observation in the form of a table. Now angle of incident, which we measured from the experiment through the protector, and angle of refraction, this is 13, while angle of incidence I per degree is 20. You can see in the first observation we observed that angle of incidence is greater than the angle of refraction, and which is quite visible from the first observation. The second is when the incident angle is 30, the refracted angle is 20, and in this way we can all summarize all these information in the form of a table. Now this table is very important because now this topic is also very important. Keep in mind, dear learners, that it will lead us to a very, very important topic, and that is optic fiber, which we will discuss in the subsequent lectures very soon. So if you understood this concept, there will be no problem for you optic in optic fiber. How through light we can transmit data from one place to another place with the speed of light. That is very interesting. So pay full attention to this topic. Okay, based on the observation, the following three conclusions can be made. That is the nutshell. Number one, that is the light passes straight when incident perpendicularly. Dear learners, when a ray of light is incident perpendicularly to the boundary or along the normal of two media, it passes through without bending, although its speed is lower in the optically denser medium. That is the first conclusion. The second conclusion is when a ray of light is incident at an acute angle to the boundary of the media, the refracted ray bends towards The normal when light travels from an optically less dense medium such as air into the optically denser medium such as glass. So the converse is also possible, dear learners. That is, the light ray is bent away from the normal when it travels from a medium such as glass into an optically less dense medium such as air. And I told you that in greater detail a few moments back. Now, the third is very, very important, and that is the ratio of sin I and sin R is constant. This is extremely important laws which is formulated by a Dutch mathematician with the name Professor Willebrord Snell. So these two laws which we are deriving with the name laws of refraction is also known as Snell's laws, after the name of Dutch mathematics professor. The third conclusion is, unlike the case of reflection, where the angle of incident I is equal to the angle of reflection R, the relation between the angle of incident I and the angle of refraction R is more complex. Yes, that is complex. In case of reflection, it was easy. In 1621, a Dutch mathematics professor, as I told you, by the name of Willebrord Snell, discovered that the ratio sin I divided by sin R gives a constant. Alternatively, we can also see the relation between I and R if we plot a graph of sin I against sin R. We should obtain a straight line graph. It means constant. We learned that in the second topic of this course. With a constant gradient, the gradient is constant. Everywhere, if you are finding the gradient, it will be the same value. So let us show that the Snell's law is in this. We are taking all these values and finding the sign of this and the sign of this through calculator. Now, many people, I heard that they are pronouncing it as sin. It is not sin. It is a trigonometric ratio which is called sine, and that is the ratio of perpendicular by hypotenuse. So this is the table in which incident angle when 20 and refracted angle is 30. When we find the sine R, when we find the sine of I, it will give you 0.34, and when it give you sine R, the refracted sine 13, it will give you 0.22. And when we divide sine I by sine, yani this value by this, it will give you 1.5, and all the other ratios are calculated in this way. So these are the values which we get from the ratio of sine I and sine R, and you can see that these values are the same. In other words, we can say that all these values are constant: 1.5, 1.5 and 1.5. Similarly, if we plot these values in the form of a graph, best fit line will show you that this is a straight line. So it means it is constant. Whenever you are finding the gradient of this line, you have to take two lines anywhere, like here or here, whatever convenient to you. This is the rise and this is the run. So when we divide run by rise, in this case you will see that this is 0.6, 0.2. So we have to subtract from this 0.6 this 0.2, which will be 0.4. And in this case on y axis, that will be equal to about this value, and that is 0 point something. Let us consider it 1. So when we subtract this 0.4 from 1, so it will be 0.6. So if we divide 0.6 by 0.2, 0.4, then we will get a value. And similarly this case, in this case. Now this is a topic of mathematics. I'm not going in the detail of that. For mathematics classes and lectures, you can see my lectures on mathematics as well to clear your concept. Now we are in a position to summarize the two laws of reflection. The two laws of reflection. But before that, two laws of reflection, let me tell you that we are summarizing the conclusion we made few moments back from the experiment, and now we will summarize, and that will be the two laws. Now let us first say something about the first law. The incident the incident ray the normal and refracted ray all lie in the same plane, and that is the verdict same is in the case of first law of reflection. They all are lying in the same plane. Now the second one is for two particular medias, for two particular medias, the ratio of sine I and sine R is a constant, is a constant, and we discussed this in greater detail few minutes back. Now we are turning our focus to the refractive index, which is also very important topic for optic fibers. Ladies and gentlemen, very simply I can say that refractive index is the ability of a medium that how much it can bend a light towards the normal. If a medium such as water is reflecting the incident ray less, then we are saying the refractive index of this medium is less, means that it can deviate the incident ray path less. Similarly, if we are using a glass slab, so we will say that the refractive index of this medium is greater as compared to the water. What does it mean? It means that it can refract, or in other words, it can bend the incident ray coming from the rare medium to the optically denser medium much more towards the normal. So refractive index is always denoted by n in physics, and that is equal to the ratio of sine I divided by sine R. This is called the refractive index. And I told you that for the case of a light ray passing from a vacuum or in practice air into a given medium such as water, the constant ratio sine I and sine R is known as the refractive index n for that medium, and mathematically we can write that refractive index to be like this. Let me also tell you, dear learners, the greater the value of the refractive index n of a medium, the greater the bending of light when it passes from air into that medium. Now table is given to you, and the table is showing the refractive indices of some optical media, of which diamond has the greatest refractive index while air has the smallest refractive index. That table is, let me put it in front of you. That table is this one. So let us see that the table is, no, it is not this table. We have to see the table, that where I can find that table, and it is here. So we are also putting that table here in this case. Now the table is showing us that there are many different mediums, medias in which the diamond is having if we are seeing this diamond, the refractive index is 2.4, means that the ratio of sin I to sin O is 2.4, and the speed of light in it is 1.25. Similarly, glass depends depending on the composition of the glass, but we are saying average as an average about 1.5. For glass, the refractive index varies from 1.48 to 1.96 depending on the composition of the glass. So we took an average of those values, and that is 1.5. That is why we are saying here about, and here also the speed is 2 into 10 raised to the power 8. Similarly, perspex, water, ice, air. Air is having the smallest uh, refractive index. Now let us see that diamond is having a more refractive index than greater refractive index than anyone else. They can bend the light because they are more denser, so they can bend the light very much towards the normal, and that is quite clear from the table as well. The diamond is having the greatest refractive index while air is having the lowest of the refractive index. The table also shows the speed of light in each optical medium. Note that the speed of light in diamond is the lowest, since diamond is the optically densest medium compared to the other. A material with the larger value of refractive index is an optically denser medium. So you have to keep all these things in the mind, and refractive index and the speed of light also. And if in vacuum, the speed of light is found to be about 3.0 into 10 raised to the power 8 meter per second. That is vacuum, and that is 3.0 into 10 raised to the power 8 meter per second. As mentioned earlier, the speed of light decreases when it travels from vacuum or in practice air into an optically denser medium such as glass or water. From the wave theory of light, it can be shown that for light passing from a vacuum into medium, refractive index for the medium, refractive index for the medium will be equal to speed of light in vacuum divided by speed of light in medium. You have to take the ratio with vacuum and with the medium, then you will be able to find the refractive index of medium if we want to find. So technically we can write that n is equal to c divided by v, where c is the speed of light in vacuum and v is the speed of light in medium, which you want to compare. So this is also very important mathematical form. In tomorrow's lecture, we will do work examples on this very important uh, equation, and there are many things for you people to learn in that, so stick to this channel. And if you are new to this channel, welcome, and if you have subscribed it, thank you for your loyalty and supporting me. If you haven't subscribed yet, please subscribe it so that you will be the first person to receive the notification when I upload the new video. Thank you very much for your time. Allah Hafiz.